Hi, students. Let's look at this question, which is on application of integration and also the integration techniques. I think let's look at the first one. So we are asked to find the integral of x over root 2x minus 1. I think firstly is to understand that this is actually by two parts, right? You can't do cancelling method. So what you need to do is just, this is by parts where you have two a's here. This is a, this is also a. Then usually if you have two a's happens, right, you take the one with the lowest positive integer. So this is positive integer x about 1. So that's your u. And your u is x, then your dv dx will be the other one, which is the it could be an integer, could be a fraction or so on. Okay, so this case is a fraction. So du dx will be 1. dv will just be 2x minus integrating it plus 1, which is half, divided by half, then divided by 2, right? Don't forget to divide by 2. Okay, so this is it. So we're gonna use product, by parts. So uv, so that will be x square root to x minus 1 minus of this 2x minus 1 power of half dx, right? Then this is just secondary school integral. 2x minus 1, 3 over 2, 3 over 2 divided by 2 plus c. So this is the answer here. You can just leave it as such, okay? Part B by using substitution. So I'm going to just copy this question down. So our goal here is to essentially just make sure that we change this to dt and also change everything to in terms of t, right? So in this case, I'm going to just dt dx, right? dt dx will just be secant square x. So this case here, dx will just be dt over secant square x, right? So we could just replace everything in, and we just try to change everything to in terms of t, right? That's the whole idea there. But it's not so straightforward because the thing is, we how do we change cosine x square x sine square x to t? Draw the right angle triangle. Okay, just draw a right angle. As long as trigo is constant, always draw a right angle triangle. Here, this case here, what I can do is expressing cosine theta and sine theta in terms of t. So this will be tangent x will just be x t over 1. Okay, t over 1. So this we have a t square plus 1 square root. Okay, so that's it, tangent x. So then this case here, what we get is dx is equals to, this is cosine 1 over cosine square, right? I just write this as secant square x. So this is dt over 1 over cosine square x, which is cosine square x dt. Now, if your teacher don't allow you to write this, just erase away. It's okay. It's fine. Just re-erase. So basically, dx is this guy. Okay. So this case, what we get is 4 cosine t square. So cosine x will be 1 over t square plus 1. Sine x will just be t over t square plus 1. Okay. That's that. So then you just square both sides. So this case, cosine square will just be squaring the entire thing. 4t square plus 1 square plus 9 sine square. Square this entire thing here as well. So that'll be t over t square plus 1 square. Dx will be this thing here. So cosine square x dt. Alright. That's that. So cosine square, we could just square it also. Then we just try. Then what we can do is essentially just simplify this. We get t square plus 1, 4 plus 9t square. Then this is t square plus 1 dt. Okay, so the whole ordeal here is to change everything in terms of t and a function of t. So we get this. Not an issue. This will be 1 over 2 square plus 3 over t square dt. Remember, this is using MF27. Okay, so we will suggest, or you can just write this down as factorize the 9 out. That will be easier. So this case will be 4 over 9 plus t square. Okay, this will be better because this one is less prone to careless. So if you 1 over 9, this will be 2 over 3 square plus t square dt. This will just be 1 over 9. 1 over tangent inverse, right? So tangent inverse, that will be tangent inverse t over 2/3 plus c. Okay, so this case here, what we get is, we get this. Then we just change it back to t. So 1 over 6 tangent inverse 3 over 2. T is actually tangent x. So I'll just put this as tangent x here. There you go. This is the answer. Okay, in terms of x. Then whereas for this guy, if you want to do it straight, it should be 1 over a tangent inverse 3t over 2 divided by 3. Okay, a lot of students will always forget to divide by this 3 here, so just remember divide by 3. This is 1 over 6 tangent inverse 3 over 2t. Let's say this is 1 over 6 tangent inverse 3 over 2. Okay, we usually suggest students to take the coefficient out, but tangent x, t is tangent x. Okay, so that's how you do this question here proficiently. So let's look at part C. So part C is a very typical Riemann sum problem. So the diagram above shows part of y equals to x squared plus 3x. So this is y equals to 3x squared plus 3x. Then we are told that the area under the graph from 0 to 1 here, with 0 to 1 here. Here, 0 to 1, then we are looking at the area under the graph here. So this is what the area that you want to find, right? The integral between from 0 to 1. Okay, the area under the graph could be approximated by n minus 1 rectangle. The reason why is because the first rectangle here, you can assume it to be a flat rectangle. You're taking the right bound, right, for the height. So this is the first rectangle, 1, correspond to this one, 2. Then you have 3 over n. This is the third one. Then this will be the n minus 1. So you just take note of that. Okay, so each with width of 1 over n. So this width here is all 1 over n. Similarly, this is 1 over n as well. Okay, there you go. There you go. So now, finding the area of rectangle under the graph shouldn't be an issue. So you think about it, right? You're taking, this is the width is 1 over n. The height here will register. Okay, I'm going to let fx be, I don't want to keep writing, so I'm going to let fx be x squared plus 3x. Okay, so if I look carefully, the height of the first rectangle, it will just register f1 over n. That's it. This is 1 over n. Okay, then you have got the second height here will be f2 over n, the height. But take note, the width of each rectangle is 1 over n. So if you want to find the total, so third triangle will be this. Now eyeball the first rectangle and the last rectangle. So the last one will be f n minus 1 over n. Okay, you're taking the left. This is the left Riemann sum. Okay, left Riemann sum. So this case here, once you're done, what we can do is just sum them up. So A will be 1 over n. The first rectangle, which is this one, the first rectangle is this guy here. Right? Okay, this guy. Let's look at this rectangle here. That will be, the width is 1 over n multiplied by f1 over n plus 1 over n f2 over n plus 1 over n f3 over n till the last one, which is like 3 over n plus plus 1 over n, then fn minus 1 over n. Then what we do is we just factorize the 1 over n out. Okay, we get is f1 over n plus f2 over n plus f3 over n. Then you write in the sigma notation form. I think that'll be great. n minus 1 over n. So I'm going to put in sigma notation form. Here, what we get is 1 over n summation of r equals to, you start from 1, 2, 3 to n minus 1. Okay, so 1 to n minus 1, essentially the running number is r over n as such. Okay, so from here, what we can write it down is 1 over n r fr minus, so you just fr over n will just be r over n squared plus 3 over r over n. Okay, that's it. So here, we're going to do just, I'll get the fr over n squared plus 3 r over n. Okay, that's that. Then expand. Here shouldn't be an issue. I think the first thing is understand that linear is a AP. Then this one r squared we already gotten, and then I'm just going to distribute it in. Okay, distribute this in. I'm going to take the constant out, which is the n squared. So this is 1 over n. R1. Distribute it in. Bring the constants out. Okay, then I'm gonna just get, this would be then this guy would be the formula given to us, which is this guy here. This guy is an AP. Okay, a linear will be an AP. Linear is an AP. So we replace n minus 1 into the formula, n minus 1, which is this guy here. Okay, where you go? N minus 1, n minus 1, n minus 1, n minus 1. Okay, just replace it in. So this guy is this guy. I just replace n minus 1 into the formula given. Then, oh, sorry, not this. I mean, this guy is this guy here. Okay, so then what we're going to do is just, this is 3 over n squared. This will be 1 plus 2 plus 3 all the way to n minus 1. So this is an AP. AP formula, number of terms divided by 2, first term plus last term. Try not to expand everything. Just leave it in a factorized form. It's always better to do that. So this will be 1 over 6, n minus 1, n. Then 2n minus 2 plus 1 minus 1 plus 3 over n squared. And number of terms, this is number of terms, all divided by 2, first plus last. Okay, then you try to factorize everything. So I'm going to factorize n squared out first, 1 over n squared. Then left with 1 over 6n, n minus 1 to n minus 1, then plus 3 over 2, n minus 1, n. Okay, so what I can do is factorize the n minus 1 out. So you see the formula given, is there n? Yeah, there's n and n minus 1 there. Actually, I could cancel the n here, sorry. So just cancel this n out. Okay, then I factorize the n minus 1 out. This will be 2n minus 1 over 6 plus 3n over 2. Merge them together. Here, then I'll get 11 n minus 1, 11 n minus 1 over 6. Shown. Okay, there you go. Done. So the next one, explain briefly how the value of 0 to 1 can be deduced from this expression. Remember, this is the entire area in the graph. If you take this exact area of this shaded area here, this will be 0, 1x squared plus 3x plus dx. Remember what Riemann sum does is actually, this is actually what happens. This is the graph from 0 to 1. So if you use n equals to 6, obviously the area under the graph, there are a lot of gaps here, right? So if you use like 4 rectangles, it's not a good estimation. But what happens if you increase the number of rectangles, it becomes infinitely small and it becomes the actual area under the graph. Okay, so that's the idea that what we want is actually when we take n goes to infinity, the area under the graph would just be the area of the rectangle itself. So that's what we meant by as n goes to infinity. Okay, the area tends to the actual area on graph. So it's 0, 1 x squared plus 3x dx. Okay, actually. Then so hence we just use 0, 1 x squared plus 3x dx. You could just write this limit n tends to infinity. We put this as a. Okay, so this limit n tends to infinity, n minus 1, 11 n minus 1. Oh, sorry, there's a mistake here. There's an n squared below. Yeah, so there will be 1, 6 n squared. So we just try to find. So you could either expand and then just find the, what do you call it? You could just do long division. Okay, it's possible to expand and do long division. You don't really need to do what we try to do, but we tend to, what we do is we try to manipulate. We get 1 over n. Okay, we get 1 over n out from this expression here, so we just multiply by 1 over n. Multiply by 1 over n. Okay, cause the 1 over n, just take note, you have to pick one of the factors to multiply. So the 1 over n multiplied with this, 1 over n multiplied this, but this 1 over n will cancel off the bottom to get 6, right? So limit n infinity. This is the quicker way. 11 minus over n over 6. Okay, so as n infinity 1 over n goes to 0, so hence this will just be, so when limit, this will just be 1 minus 0, 11 minus 0 over 6. Okay, so this is 11 over 6 square units. Okay, so that's how you do these Riemann sum questions here. Okay, so if you have any questions at all, please do let us know and I'll see you in the next question.